Okay, so this is some basics for trig. Okay, first of all, we need to talk about labeling triangles. Uppercase letters are used to represent angles. And what do you think I use to represent sides? Lowercase. When you have a triangle, you have 3 angles, right? And they add up to how many degrees total inside a triangle? 180. The letters that are given to sides are located across from their angle. So label the triangle beside here. So if this is angle Z, side Z is across from angle Z. So where is side Y? Across from angle Y. And side X is across from angle X. Okay, we're going to label these. So 5 is across from the angle with a square. So I'm going to call side 5 the square side. Seven is across the angle that's labeled with a star. So I'm going to put that beside the 7 to show you that that's the star side. And the X is across from the circle angle. Can you do that to this? 12 is the what shape? 12 is the circle. 9 is the shape of square. And Y is across from a star. Okay, we're going to set up ratios to solve. Okay, these triangles are similar triangles. So what's the definition of a similar triangle? They have the exact same angles. Do these two have the exact same angles? Yes. They both have a square, they both have a circle, and they both have a star. They have the same 3 angles, so they're similar. So that's the definition of similar, equals all the same angles. Do you know on Word when you drag an object? I love when people finish my sentences with my things. Okay, if I draw a triangle and I draw the same triangle but I drag it bigger, does this make sense that these triangles are similar? Do you know what I mean? Like pretend you're dragging something, right? Okay. So those triangles are similar because I dragged it bigger. Okay, so similar. They have the same angles, but it's like a document where you drag an object. Okay, the ratio of this side to this side should be the same as this side is to that side. Do you understand ratios? Okay, so the 5 to the 9, I'm matching the square to the square. The ratio of the 5 to the 9 should be the same ratio as, now we got to match another shape, the small circle to the big circle, x to the 12. Okay, an all-important math skill. Maybe you've learned it somewhere along the line. To solve two fractions like that, it's a cross multiply. Which two numbers can I multiply diagonally? I'm going to go 5 times 12, and then I would divide by the last one. So 5 times 12 divided by 9. And that's the length of x, the side x. Okay, let's try that again. The ratio of this 5 to 9 should be also the same ratio as what to what? These two sides should be the same ratio, so 7 to y. Do you notice how I'm writing them always the smaller triangle to the big triangle? Does that make sense how I did it? Which two numbers would you multiply and which one would you divide?
9 and 7 and divide by 5.
Times, it has to times on a diagonal, so 9 times 7 divided by 5. So 12.6 is the side y. Yes. Okay, number 2, I need you to start me with some labels. So I'm going to put a box around 21. Around x, I'm going to put a circle. Around y, I would put a box. Around 6, I would put a circle. What, do you want to put something else on the missing one? There's a third one. A star. So this angle would be a star. If this is a star, what's this one? Also a star. So I'm going to put a star around 12 and 4. Okay, which two do we want to use as a ratio? 12 and 4. That's what I'm picking because they're two numbers. So the ratio of 12 to 4. 12 to 4 is the same ratio as 21 to what matchup?
Y.
To y, because it's the box. We boxed them. The 21 to y is the same. So do you see what I did? I had to match the two in boxes together. Okay, now that we have that set up, which two do we times? 4 and 21 and divide by 12. 4 times 21 divide by 12. Okay, so now I'm going to keep the same ratio we started with. So we already matched up 12 and 4 with each other. So the match of the 12 to 4 is the same match as, and now we got to go with the circles. How do you write the circle matchup? X to 6. These two should be the same rate of change as those ones. Okay, you're going to pick two things to multiply and something to divide. Multiply across, divide by the leftover, I always call it. Okay, so similar triangles, matching up ratios of sides. Okay, I'm going to take this drawing. I'm going to split it into two separate drawings. So I have a small triangle and a big triangle. Do you see that? There's a small triangle. That's my small triangle. And this is my big triangle. Okay, the small triangle will have an X and a 5 on it, right? The big triangle will have a 12 on the bottom. This side of the big triangle is not 21. 21 is only this portion. Does anybody know what the whole side length is here? How do you represent that with math? 21 plus x. For instance, I'm just going to pretend x is some number. So if x was, say, 10, it would make that side 31. Okay. Can you set me up a ratio like we did? What to what is the same ratio as what to what? So 12 to 5 is the same ratio as 21 plus x to x. Does that kind of make sense? It's the same thing, it just was a little bit more complicated looking because that side was not a number. Okay, we're still going to do the same kind of strategy. Cross multiply. I need you to multiply like that. So this will make a 12x equals, do you understand timesing that? You're going to have to do a times like that, a distribution on the 5. 5 times that. Does that make sense? It's a distribution timesing. Everyone's okay with that distribution? 5 times all that, yeah. Okay, what do? What's your algebra step? You're trying to get x here, so what am I going to do? You're going to need to subtract 5x because you want the x's now grouped together. So that would go. So 12x subtract 5x can be together now. I need another algebra move to get x alone. Divide by 7. So x is 15.